So yeah, just remind me to press the record button if I forget it. And yeah, I'll try to press the record button as well. But yesterday's class, I think I can do a quick recap any day, but no worries, it's not in the midterm. The class, what's that? Which class was it? So just to be specific, so the midterm will be up until class 11, class 10, class 10. Class 11 is not in midterm, although it's very related, but no questions from this will be in the midterm. And today we are going to do the midterm question review. So the review class. So I would say like if you didn't study for anything, just focusing on today's class will ensure you get, like if you pay attention, you can get 90 or 100% just focusing on, because I try to keep my midterms close to the practice sample question, but the MCQs might be different, but the pattern would be the same. Another thing I figured out that handing out 200 scripts is a challenge. I thought of, and even after handing out scripts, it has been checked by different TAs, right? And then like, so for quiz one, if you have any question with the grading, you bring it to me after class, after class, or during office hours. Before class, it's a bit hectic for me, but from the midterm and the quiz too, I thought I will organize it by the TA who has checked it. So each of them will have a folder, and if you have a problem with it, you can go to the TA who has checked your script. So that's my plan. Yeah. Oh, also you have this due. So this online quiz, it's just for practice, the open book online quiz, but it's expected that you do it by tomorrow midnight. So you can start now. In most cases for Canvas quizzes, you have a 2-hour time limit after you start, but I set the time limit to like no time limit. So you can start now and like continue after 5 hours, have breakfast. So you can do that. Like you don't have a time limit, but try to finish before, well, I can extend it by like try to finish before Friday midnight, okay? Try to finish before Friday midnight. And some of you have, like some of the questions need a bit more, like you can interpret it in different ways. So some people pointed out that there could be like another option which is not like exactly correct but close to correct. So I will give everyone benefit of the doubt, but after the all of you have finished the quiz, it's just there for practice. So just there for practice, but you know the Canvas quiz will have around 4 to 5 MCQ quizzes, and 10% of the grade will be from this. So don't worry, but it's just open book, and you can search the internet for the answer. Yeah. So and yeah. So I think 3 or 4 of the question everybody will be getting marks. So it's just 20 MCQs. So you can start now and continue later, but not for all courses though. For other courses, you have a 2 hour time limit from the time you start. So, but I removed that. Okay. Uh your midterm. I also changed the assignment dates because I didn't want to burden you with the midterm and the assignments all together. So I extended the assignment date. So assignment 4 is due on the 29th, and assignment 5 is due on November 7th. So just so that you don't have to worry about the midterm. Okay. So let's start the revision for the midterm. I'll get my pen out. Chat. When is the midterm? Yes. Okay. I forgot to record class 11, but it's not in the mid. And I will do a recap soon. Okay. Module. Another thing I'm planning to do is your quiz 1, you got like 70% average, but I was expecting 80%. So in the final, I will curve it to like the quiz 1 to 80. So you'll get a bump for quiz 1. Hopefully, I'll see at the end, but no promises, but I plan to do that. Okay. Okay. So if you open the, wait, I'll open it with toxic. If you open the sample midterm, you will first see that I provided the solutions first, because like some people might see the question and if might not find the solution. So I provided the solution first. But if you want to practice at the end, I have a version where after the cheat sheet, I have practice questions without solutions. So you can practice here. But I didn't want people to miss the solutions. Okay. So the MCQs, they are pretty much straightforward. And I have provided some explanation for one of them. For example, this one, I provided an explanation here. So but I only provided explanation for this one. Most of the multiple choice questions are self-explanatory and could be found from the slides or could be easily deduced. Now let us go for the long questions. So here for this question, uh, we know that the little endian and for the big endian, we know the standard is little endian, right? And let's just follow one way of defining them, not to confuse you guys. So if you comment pencil, so we have this, wait, okay, this is, okay, this drawing should be better. Okay, so if you have a number 51, 52, 53, 54, right? And if you need to put it into little endian and big endian format, let's just follow one common rule where we put the addresses like this, right? And if we are doing little endian, we can easily put them in because you know that the least significant bit goes in the least significant address for little endian, and little endian is the standard. So if we quickly put this in, uh, what I like to do is put it in this order and then just copy the number over. So that's simple. For big endian, if you keep the address same, so this is little endian, and this is big endian. So for this one, we just do it the opposite. But remember, big endian is not standard, and so the only question you will be getting are like this. Like if you want to sort a 32-bit number into little endian and big endian format, how would you do it? So that's it for big endian. We won't be doing giving you some command, and like these type of questions will only be asked for little endian, which is the standard, not for big endian. It will be like hassle for you. Although I provided solution before the quiz one, but I won't ask a question to do like solve this for big endian. Okay. So everybody understood how we can put values for little endian and big endian if you get one of these questions? Okay. Now let us do this question, which is, yeah, I'm just waiting for the zoom in function. Okay, so this question asks, like, assume S0 refers to $0. Okay, so by this, I mean that value of S0 is in dollars S0. Okay, and it says the address of A is in $S1. The value of I is stored in T1. So value of I, it's in $T1. And address of A, this is stored in $S1. Okay. So we have to understand the question because some of you got deducted a little bit marks because you didn't understand the address or the value. Here, S0 equal this means that the result of this will be stored in $S0. So that's what it means. So you don't have to do a store word operation. Some of you did a store word operation you thought that the address of S0 is stored in this one. Okay, so understand the question first. But if we try to do this, what's the first thing that we notice? It's that the offset of the array. So the offset of the array is a variable. So normally when we have like values like this, right? What do? We do a load word. If we want to store, like, let's say we want to store in T0 this value, what do? We do a load word and we store it to T0 and we provide the offset. So A, the base address of A is in S1, right? So we provide the base address and we multiply the offset with 4. So 5 4s are 20, right? If we know what the offset is, but in this case, the offset is a variable and we cannot do that. So what can we do? We can multiply the variable with 4. So let me just clear out the additional things. Because we don't have a fixed offset, we have a variable offset. Therefore, we need to multiply I into 4. And now you can do it using SLL. You can also do it using the mult command. If you use the mul command, you'll have a slight point deducted. So I'm just showing you how would you do it with the mult command. So if you want to do it with the mult command, you have to store 4 into another. Let's just quickly do it. So load immediately. We want to store 4 in T5, right? And then we want to multiply I, which is stored in T1, with 4. So 4 is stored in T5. And then we can store the result in move from low into T2. So this is another option that you can do instead of using the shift left logical. You can either do this one line or this.
Question.
Yes.
Mul instead of mul for this one, right?
But mul is a pseudo command. That's why I am I'm restricting some of the commands which are pseudo, which is except you can use these pseudo commands: li, load immediately, load address, and the bge, bgt.
So you won't use mark when you use mul.
Yes, you want to use mult. If you use mul, you will get like a 0.5 deduction. Let's say the question is 5 marks, you'll get 4.5 if you use mul. So we are using mult because it's a pure instruction. Okay. So with this first line of code, what we are doing is we are multiplying the offset into 4, and then we are adding the array base address. We're adding the base address of the array with the multiplied offset, okay? And we now have, in T3, we have the location of, in T3, we have the location of A of I. So not the value, location. So because in T3, we have the location of A of I, we can load it. So from T3, we are loading the value of A of I. So after this line, value of A of I is stored in T4. Okay. And now once we have got this part, we just add 5 to it. So add 5 to T4. Any questions on this? Yes. Yes, you cannot. I just did it for consistency, but putting 0 here is optional, but you should do that too, so you remember that this is how the load command looks like. Yeah, but it's optional. So basically, it's really easy. We multiply I into 4 here, and we have the offset multiplied by 4. We add the base location with the offset, and in T3, we have the location of A of I. And finally, we get the value of A of I in T4, and we add 5 to it. So if I give a easy question like this in the exam, I expect everyone to get it correctly. Because this is like, there will be a easy question similar to this. Any questions on this? Yes. A
The I became 4I instead of I.
Yeah, just like A of 5, right? A of 5 becomes because I know 5 is I know 5 is not a variable, right? I I do the load command. If I needed to put the value in T4, I would do this. We are multiplying 5 into 4, right? Multiplied by 4. But we don't know what I is, right? That's why we needed to use SLL or mult to get the 4 multiplied by offset. We have to multiply the offset with 4 if it's an integer array. And that's why in this question, this time I specified it's a word array or an integer array, which each value take 4 bytes. That's why we multiply by 4. But if it was a byte array, then we don't multiply by 4. So because here we multiplied by 4, that's why the offset we provided is 20, right? But we could do the same thing for 5. We can multiply, put it in a register, right? Multiply it, add it to the base address, and let's say we store 5 multiplied by 4 and the base address into another register, T6, right? And then instead of doing this, we could have done load T4 directly from T6 with a 0 offset because we put it in there. Now T6 is already has the location, so we don't have to add the offset. So yes.
So for infinity array, it's like a array of outward. And the first time will basically shift that by 1.
By 2, like multiply, then you have to multiply by 2 instead of 4, right?
T2, T1, and then 1, because 1 is like the power of 1.
Can you repeat the question? SLL?
Power 1 and 2. Suppose this is 2 because we're shifting 2 to the power of 2 4 bytes.
Yes.
Say
Half word, then you would do 1, but I'm not trying to confuse everyone with critical questions. I'll keep it easy. The midterm will be easy. Okay? Yes. But I'll try to keep it in an integer format so you can use shift left logical too. I won't give half word or character for the easy question. The final might be hard. So yeah, but the midterm will be easy. Okay, so this looks basically you had one of these in your slides, right? But I try to make it complicated, right? But just focus on the basics. And it will be a little bit complicated, but not as complicated as this in the midterm. But if we can solve hard questions, like complicated questions, we'll have an easier time with easier questions. So, the first thing you have to notice is it's a loop with a smaller equal sign, right? So what's the opposite? Opposite. So the opposite is greater sign, not greater equal, but just greater sign. So that's what we have to think when we are coding in MIPS. When does the loop break? The loop keeps on going as long as it fulfills this criteria. So we have to think, when does the loop break? So it breaks when it's the opposite, which is greater than. So you can do it in other ways, but it's easy to think like this, and you end when our I. So in the question, I said the value of I is stored in T1. So, and the array A is stored in S1. So that's why I'm checking whenever I is greater than 5, if this condition meets, end the loop. Okay? So first, when we are marking your mid script, we will look for whether you correctly ended the loop or not. Now, you might get partial marks if you do branch greater equal, but it will be slightly incorrect because it's not the opposite. Yeah. Oh, yeah. Branch greater than 6, then you'll be good. Yeah, just don't complicate things. Keep it simple, and we will look for correctness. So if you are right, you might be graded like down at the beginning, then you come to me. But if you are right, you'll get the grade. But we will look whether you are right or not in this line. Secondly, let's just fulfill what do we have to do for the loop to run, right? So in order for the loop to run, we have to do I++. So we do that at the end. So here you see I'm adding T1 equals to T1 plus 1. So I'm doing the I++ here, and then I'm again looping. So that's our loop. We are done with our loop. Make sure you don't forget to increment I and then jump back to the loop. So this is our loop. And inside we have a complicated function, but you have done complicated functions in your assignments, right? So basically this function says 5I square minus I divided by 10. Now I have provided the in the reference, you can find how to use mult and diff. So I'm just quickly going to the reference sheet. And I feel I put too much comments in, which might confuse you in the exam. So I tried to simplify it. If you want to multiply two numbers, two registers S1 and S2, and get the result in S3, you do these two lines. And this will be inside your reference cheat sheet. If you want to divide two numbers and get the result in S3, you do these two lines. So in the exam, make sure you use the reference sheet. Okay, now going back to our solution. Okay, so here we know I is stored in T1, so we are getting the I square first. And after getting the I square, we know we have to multiply it with, so S5 has I square. After I do mult T1, T1, and then the result is stored in S5, okay? In these two lines, I do S5 equals I square. Now, for mult, you have to put it in. We now need 5I square, but we can directly multiply 5. We have to put it in a register. That's why I load immediately 5 to T3, and then I multiply T3 with S5. So like I have to put 5 in a register first. If you do like this, you will get like a 0.5 reduction, because we know that you are on the right track, but it's not correct. So it's a like minor mistake. You can't do that. So you do this. Similarly, for division, we can't divide by 10. We first have to put 10 in a register, right? And then we divide I by 10 after putting 10 in a register in these three lines. We first put 10 in T3, then we divide, T1 is I, so T1 divided by T3 and put the result in S4. So S4 has this and S5 has this, okay? And now we just subtract S5 minus S4. So S5 minus S4, we get our result in S6. And finally, you see here, for this array, I, the offset, is also a variable. That's why we have to multiply the offset into 4 and then add the offset to the base address, similar to what we did in the previous problem. And then finally, we can store the result that is in S6 to A of I. Okay. Basically, in this part, we do the calculation and store it in S6. And in this part, we find the address of A of I. And in this line, we put S6, we put it inside the address of A of I. Okay. And then we do the loop until it ends. We did the loop first. Any question on this? Oh, for some reason, when I plug my HDMI inside this laptop, it freezes. I'm just going to switch to the, what do you call it? Air media. Yeah. Oh no. Okay, no, I'm not switching because I think it happens when yeah, let's just go with what we have. But any question on this, like you can ask. Yes.
Consideration offset would be zero, right? On the line SLL $sign T2.
Yes, offset is zero because at the beginning, you see, we put T1 as zero, which is I. So yes, the offset is zero. And you can figure out a different way of adding. You can do that. You can have your own solution. If it's correct, it will be graded correctly. If it's not graded correctly, you can bring it to me. It will be uh, updated. Yes. You are. I'm going to list down. I have provided the list which pseudo instructions you can use. I'm going to update it, but you can use the LI, well, LI, LA. I'll do it in a fresh page here. So you can use LI, LA, the four BGT, uh, BLT, those four, BGE, BLE, those four. And that's it. These six instructions. Did I allow any other instructions? No, store word is a normal instruction. Store word is a let's just tell you what you can't use. That will be simpler, right? You can use it, pseudo instructions, you can use it, but you will get a slight deduction if you use MOV, move, MOVE, and mul. Yeah. And you have to use the div in the way I provided in the reference. You can't use, like, if you use a pseudo instruction, you will be deducted marks, but you can't use these. Okay. The move, mul, these ones, these three. Any questions on this? Basically, get the loop right, okay? And first think about the loop. Is the loop running correctly? And then do the calculation in the middle. You can use a pencil, right? Because you can make mistakes. You might need to edit stuff. So I recommend using a pencil to write the code. So it gives you, like, saves time. Yes. BEQ, BNE and BEQ, those are pure instructions.
Yeah, I mean, like the register.
Oh, I think that's a pseudo instruction. Yeah, just put it in a register. BEQ can do immediate values. Yeah. Okay. Should we move on to the next question? Yeah, I think, yeah. Okay, so this is similar to what you had in your quiz. So let's start fresh from the practice question, which doesn't have any markings on it. Okay, so for this question, it will, I won't give you big Indian addressing, right? I will give you little Indian addressing, and some of you have forgotten, like, did it the opposite way. In that case, it's really hard to give you marks, you know? Just remember, in your exam, there will be a question like this in your midterm. Oh, that's why I think it was lagging. Maybe. Okay. So in your midterm and in your final, you will have a question like this, and it will be in little endian format. So when you are putting the values in, it will be easy for you to just, oh, now it's good. Yes. I just needed the, okay, 1A, 193C. So remember, you have to put it in like this. Because if you put it in the other way, then it's really hard to give you grades. Okay, so the next word, it's put in 1 2 3 4 5 6 7 8. Okay, and the next we put in 0 0 0 0 initially, but immediately we change it to, like, we immediately change it to 11223344. We do it in this line. So we put this value in register T0. Let us just write out register T0. And then we store the value inside register T0 into the location of T3, because we loaded the address of T3 in the array T3 in the register T3. That's why we are putting in the value of T0 into T3. So this becomes 1 1 2 2 3 3 and 4 4. Okay. Now I have made some changes to it to make it a little bit more tricky. So load byte, right? Which byte do I want to load? It's from T0. So T0 starts from 0, and the first byte, so 19, this one gets changed in T0. So this 19 gets changed here, okay? After running this line. Let me change colors so we can see how different things work. So now on this line, what we are doing is loading T0 to, but this is a byte load, right? So we load the first byte. So the current first byte is 19, and we store it into T1, but the fourth location from T1. So T1 starts from 0, but this is 0, this is 1, this is 2, this is 3. And you can see I tried to put, I put a like a number to make it easier for you guys. So we put it in the fourth location. What do we put? We put this 19. Okay. Instead of 78, we put this 19. Now we do another thing in this line. We load 99 into T0. So we replace everything with 99. And now the current value of T0 is this. We store byte T0 into the value of T0, we store it at two offset from T2. So T2 starts here, and we put it here because this is T2 of 0. This is T2 of 1. And this is T2 of 2, right? That's why we replace 34 and put 99 here, right? And finally, we load T0 with 15. But this 15 is a decimal, right? But we are calculating this in hex. So let me just change color for convenience. So when we run this line, the new value of T0 will be 0F because F is a 15 in decimal. And then when we finally, we put this new T0 because it's a store byte. We don't put in the whole thing. We just put in the first byte, and byte is 2 hexadecimal numbers. We put this 15 in the third location from T3. So this is T3 of 0, but we put it here instead of 11, which is T3 of 3. So we replace this 11 with 0F. And that's the solution for this question. Any questions on this? It's similar to your quiz, but I just made it a little bit complicated. And in the final, I'll try to make a bit more. Okay. Yes. This one? Okay. So this is the current form. This was the original form of T2, right? The T2, I just picked this out and I'm here, right? And you can see that there's like small numbers written underneath it. So these boxes are correct, right? Okay. Now, the base address of T0, points here, right? So T2 of 0 will point to 78, right? Now, so 56 over here is actually T2 of 1. And because we are replacing the third from T2, like 2 bytes after T2's base address, that's why we'll replace 34 with 99. So that's how we do it. Any other questions? Okay, so we have time for one last solve, and this and as you can see that I tried to make the questions on topics that we covered in class in our slides, right? So like no out of the blue questions. Okay, so I just did some oh, this one, it's fun. You convert it into binary and shift left 3 times, and uh, this is what you get after one shift, right? So we're trying to this number, we are shifting it by 3 bits, and we want to know what's the result in decimals. So after we do one shift to the left, we get this. After we do 2 shifts, we get this. And after we do 3 shifts, we get this. And you just convert it into a decimal. Pretty easy. And you'll have a question like this. Okay. The next question, you did this in the quiz, right? I tried to do some more like this. So one, this minus this, and we have an overflow. So if there's an overflow, there's no result. So you can just review this. It's similar to what you did in the quiz. I did another one where you actually get a result. So it's very easy, and you can see these two examples. But what I wanted to cover is the next question, which is how to use procedures, right? We had a question like in the slides. For foo1, we didn't need to save a1, but for foo2, we did need to save a1, right? But how would it look like if you actually convert it into MIPS code, right? So that's what I wanted to uh, ensure that you understand by solving this problem. So let's first look at the move function. Okay, so let's first look at the move function because it's easier. So for the move function, if we look at the move function, you would see that we used S0, right? We are not supposed to use S0. If we do use it, we have to store it and give it back. And that's why for the move function, it's optional to store the return address because move function is a leaf function. So this is optional. But what is mandatory is you have to save S0. S0 is mandatory. Okay? So what the TAs and I will be looking for if you do the prologue and the epilogue, which is the introduction and the conclusion correctly. So for your for keeping it consistent, let's always store the return address. So we are storing the return address. We are also storing S0. Because we are storing 2 registers, we need 8 bytes, 4 for each, right? We do what we do, and we give it back, right? That's the move function. Very simple. But the foo1 function, it's a bit complicated because we use A0, right? But when we are providing a move with T0, we provide it in A0, right? And after calling the move function, we need S0, A0, A1, and T0, right? So basically, we need 4 registers here because we intend to use them after we have called another function. And because foo is a non-leaf function. Why is foo a non-leaf function? Because foo calls move, right? Because it's a non-leaf function, we also have to store $RA. So in total, we need to store 5 registers. Okay. Another thing is we change the value of T0. So we have to save it after we do that. So that's what we are doing in this solution. So because 5 registers, each register has 4 bytes, that's why we are storing 20 bytes in the stack, right? Now we are putting in our RA and S0 because S0 it's a callie saved register. So we have to do it before we do anything to it. But the caller save register, these has to be done before we call the move function. And that's why you see this red thing, which is we have to change the value of T0 before we save T0. Okay. So basically, these are the callie saved. You do it before doing anything, but the caller saved, do it before move. So do it just before move. That's why we had this additional line in between. And then in order to call move, we had to pass in the argument in A0 and we called move. After we called move, we save the result, and immediately after that, before doing any computation, restore the caller save values. Restore T0, A0, and A1 because we will be using them in the computation. So restore before any computation. Okay. And then you do the computation, put the result in V0, and finally you give back the callie saved registers. But the caller saved, so before calling the move function, you have to save it. After you get back the results from the move function, you bring back your caller saved registers. So we are just looking for whether you can correctly do this in the midterm. Okay. Yeah. So that's the review of the midterm, and it will be easy if you practice this and can get this correctly. The MCQs might be a little different, but the main questions will be like this. So you can practice this and hope you guys do well in the midterm. Yeah, you can collect the scripts and yeah. And if you have, some people had came to me, they had problems in the script checking, so I'll upgrade their result now. So you can come forward if you have to.
In the first example you did, you said it was like an address.
Or in the largest. Yeah, this is correct. They gave you 1.5.
Like, why am I missing? Which one am I missing?
Yeah.
Oh, for that one, that places here we got not.
No, because this is 1.51. Could you check this and
Yeah, let's see.
I think because we still have like then usually just like
oh yes, don't worry about it.
okay, so like
Consider it as an integer.
and yeah, yes. So like you're sleeping in like T0, even T0 that's it, like with the combination. So like so for the register like you should like always you like to work with condition and
Yeah, because you need to use it, right?
so does that break the convention?
No. S0, right? If Mu changes S0, he has the responsibility to fix it.
Yeah.
But these won't be fixed by Mu. That's why whenever you get back the value, you have to fix it immediately. Because the S0 and RA, Mu will fix it, Mu will use it, Mu will fix it.
Yeah, like it's at the end of coming back for the G2 or for the G2, like
You have to do it.
I have to. But like seems like both like restore the T0 like at the end of something.
No, after Mu. Before Mu, save it, after Mu, restore it. And then do computation. Don't compute before restoring the temporary things.
Science maintain, right? So it's not the same as reserve. Yeah.
So, you have.
Okay.
I will give it back later.
Okay, you love it, yeah, thank you.
Yes.
Thank you.
Where's the additions thing? But then I looked at one of the parts and I looked at the and I looked at what it is. That's the one. One and 1.5 off.
19.
Yeah.
1, 2, 3, 4, 5, 6, 7, 8. 1, 9. Okay, yeah, I get.
Yeah, okay.
Okay.
Yeah, thank you.
This should be.
Yeah, because there was the addition mistake and then I saw the question and I lost where it from, and then it was that. Okay, thank you.
Yeah.
Sorry, I just had a question there. So I had a bit of a misunderstanding about the question when I first looked at this. I misunderstood this as being filled out for the table. I didn't realize these were also positions. Because since it's written X. Consistency. I thought that the 7654 was part of this, which is.
But did you do this
I-
later?
this was my first answer, it's just because we weren't able to have questions during the quiz. I just got worried and I wrote this out. I know this is wrong. This was my first answer. And if I was able to ask a question, I would have told you. Going back to the paper in there, I just assumed we did MCQs. So I know this is unique. I was just
Yeah.
hoping it would be.
I think I can give you 2.5. Yeah. Does that work?
I feel like just with my misunderstanding, it wasn't that the rest of my answer just affected how I explained it. If whatever you think it's up to your discretion. I just
I'll give
This
I appreciate it.
The noise.
And I just had one quick question there for the front. I just was curious what I could have done to explain better, like where I went wrong on my answer for that.
Big Indian will order this from left to right.
And I wrote this just above there.
Okay.
Yeah, but you didn't say what's the number before.
I want a full
Then-
mark ahead.
If I saw the number, because this looks, what's the number?
Yeah. Yeah, I guess the position.
Yeah. So it's hard to.
I could have done
This is kind of correct. I can upgrade one more, like. But like,
That should be more descriptive next time.
yeah, just a little bit. I think I'll avoid descriptive questions. It's hard to mark and hard to write.
Thank you very much.
Okay, what's the time? We can go outside.
Is it better to go to your office hours?
I think now is good. If you like, I just don't want the next person because I was late last time. Could you, like, there's this, okay, office hours is good. I'll just pack up for the next one. 25th.
Yeah, it's not.
No, don't use the move instruction.
Okay.
Yeah.
Okay, so I got a 0 here.
Yeah, I will just let me